Good morning, children. Hope you had a good night's rest and are ready for your math again this morning. Lesson 2 of your algebra book, 9.2, and page 419. If you turn to that, we'll get ready for the lesson, Dividing Radicals. Isaac Newton says there, the tact is the knack of making a point without making an enemy. I think that's good advice. All right. Without going ahead and reading all the two paragraphs on page 419, I think we will start giving you some examples and go over those with you. And basically we're trying to figure out how to take radicals when they're in a fraction form and simplifying them or dividing them to to the simplest form. And sometimes there's more than one way to do it, but we're going to we'll start with some very basic ones and we'll move to more complex ones. So the very first one we have, if they give you a radical sign 16 over 9. Now understand that this can be written as a radical sign 16 on the top, radical sign 9 on the bottom. You don't have to rewrite them all the time like this, but that's basically what it's telling you. So the square root of 16 divided by the square root of 3. Well, you know the square root of 16 is 4. Square root of 9 is 3, and you have now removed the greatest common factor, you have removed the root of each one of these, and your answer is 4/3, and that's your final answer. That's what we're trying to do, is remove the radicals. Okay? That's the very basic one. And example number 2, right beside that, you have square root of 3x cubed over 25. So again, square root 3x cubed over square root of 25. So the top 3 is not a perfect square. You can't do anything, but square cubed, that's 3x's, so you know the square, or x cubed, if an x would be squared, it would be a perfect square. So you can actually remove that, okay? So in the radical sign, we're going to have the 3 because we can't do anything with it, and we have 1x because we removed x squared as a perfect square. So you have x on the outside, and which was the 2x's, x squared, and we have 1x left that we leave in the middle, and the 3 we leave under the radical sign as well because we can't remove it. Square root of 25 is 5, and so therefore that is your final answer there. There's nothing more you can do. You can't find the square root of this, find the square root of that. You can't divide. You're done with that answer. Okay? I hope that makes sense to you. Example number 3, you have a square root of, sometimes you do it this way. This is also very simple. Now there's different ways to do this. If you look on the page 419 on the left side, it gives you a different way to solve this problem, but this is one of the easiest ways. If you can divide the numerator by the denominator evenly, that it makes a perfect square, that's the best way to go. So 98 divided by 2 is a 49. Okay? And so we know that the square root of 49 is 7. And so always check that. See if you can divide the bottom into the top evenly, and that answer is a perfect square, then that would be the route that you want to go. Okay? Example number 4 then gives you another problem. So you have square root, or 8 square root of 15 on your top numerator. For the denominator you have 2 square root of 3. Now the first thing you look outside of the radical sign, 8 and 2, you can simplify that. It simply is 4 because 8 divided by 2 is 4. So that's on the outside. Okay? And then on the inside, the square root of 15, again, we can't find a perfect square, but you can divide. 15 divided by 3 is 5. So all you have to do is leave that in the radical sign. It's not a perfect square, so you leave it just like it is. Again, look for division. If you can divide evenly, you can go that route and be great. That's all you have to do there. On the next page, you have example number 5. Get my table turned. So you have a square root of 48 minus the square root of 27 on the top, and on the bottom you have a square root of 3. Now that square root of 3 in the bottom simply is telling you that this square root of 48 has a square root of 3 in the bottom, that negative 27 has a square root of 3 in the bottom. So again, the best way to do this is look at division. Does 3 go into 48 evenly? It does, right? 16. So you have square root of 16 minus, does 3 go into 27 evenly? Yes, square root of 9. So now you've divided it and eliminated the denominator, and all you have left is this. And so the square root of 16 is 4, square root of 9 is 3, and 4 minus 3 is 1. And that's your final answer. So sometimes you'll have answers like, or problems like that. Just remember, if you have two items on the top and only one denominator, that denominator goes for every item in the top, every numerator that's in the top, okay? Example number 6. You have square root of 32. Sometimes they use variables. So you have 32m minus 6, square root of 6m cubed, and over square root of 2m. So again, there are numerous ways to do this, but again, let's look at division. 2 goes into 32 16 times, and m goes into m 1 time, so that eliminates. So all we have over here is square root of 16. Minus 2 goes into 6 3 times, m goes into m, that removes 1m. We have 2 m's left that we don't okay? So basically you have the 2 m's left because we divided, and that eliminated 1m. When you divide, subtract the exponent. So m1 minus m3 is m squared. And now this is now perfect squares because the square root of 16 is 4. The 3, there is no square root for it, so you leave it there, but the square root of m squared is m. So there's your final answer, 4 minus m cubed. Again, you can review those steps on your lesson, on the practice problems, but let's go into the lesson today. I'll do the first couple with you. And so the very first one, I want you to pause the video and do it. And once you have your final answer, start your video again, and then we'll go from there. And that's your final answer. Okay, number 2. You would have square root of 3 over square root of 25. You can't do anything with the top, so you leave it, but the bottom you can, so that's your final answer. Okay, wish they'd all be that easy, but they're not. Number 3, square root of 243 over square root of 3. You divide it. You're going to have square root of 81, which is a perfect square, and that's your final answer. Okay, I think you get the hang of it. You can keep doing those. Hope you have a good day. And if you have, like always, if you have any questions, don't be afraid to give me a call.